Hello everyone, welcome to the Green and Clean YouTube channel where I share my EV experiences and knowledge. My name is Vittal and today's episode is about pollution. You've heard several stories and several reports about pollutions caused by ICE car or petrol car versus EV cars. Some say there is zero pollution in EV cars, some say the EV cars pollute more than the ICE car, and today is the time to find out the truth. It's going to be a difficult task because to compare the two cars, you need to consider so many different parameters. What type of ICE car you are driving, how many kilometers you are driving, how long you want to keep that car, like the lifetime of the car, and where you are driving the car. Because if you're talking about EV, the electricity generated also causes some pollution. So that pollution depends on where you are, which part of the world you are, which part of the country you are. So there are so many various different parameters. But I'll try to do my best and draw a point and find out the truth about what pollutes more, the ICE cars or EV cars. I want to talk about an analogy before I go into the details. And the analogy is of two dogs. The first dog is a beautiful dog, barks very nicely, very obedient, but it eats a lot and it poops a lot. So it poops wherever it goes. It's not potty trained. So the dog poops wherever it goes, whether it's your house or car or wherever, right? So it poops everywhere. And the second dog is a silent dog, doesn't bark much. It eats less, but it poops also less, and it poops at designated places inside your house. So it's easy to manage the poop caused by this car, right? So now you can draw this analogy to which dog I'm referring to as ICE car and which dog I'm referring to as an EV car, right? So that's the thing I wanted to draw about pollution. So the pollution caused by EV and ICE are slightly different from that perspective. So there is that is the fact. Now I can't. I need to go back to my desk and screen share and show you some things that I'm going to present today. So let's get back there.
All right. Before I go into the actual scenarios, I wanted to explain you about various parameters that I will be using in today's demo. And these parameters will also be used in my next episode where I discuss about the costing of EV versus ICE. So let's get started. The first set of parameter is what I call as the usage. This is how many kilometers you run your car per month or per year. So roughly, I would like to call this into three categories. The first one is rare usage, where somebody uses car very rarely, 500 kilometers a month, 6,000 kilometers a year. So it's that kind of user. And then the next type is the normal usage, where somebody drives like 18,000 kilometers a month or roughly 20,000 kilometers a year. Now, this is the usage on which most of the manufacturers give warranty. For example, battery warranty usually comes for 8 years and 1,60,000 kilometers. So this is that kind of usage. And the next usage is the heavy usage where somebody is extensively using the car 3,000 kilometers a month or roughly 100 kilometers a day, 40,000 kilometers a year. So it's mostly like a fleet or a cab kind of a usage. But there are also some private owners who use the cars to this extent. So three categories of usage. And the next is how long somebody is keeping the car for. Short term, I would call like somebody keeping the car for 4 to 5 years. And then a normal term is, let's call it as 8 to 10 years. And then the lifetime, I'm considering 15 years as a lifetime of a car. Of course, the cars can last longer than this, or sometimes um, can die before 15 years, but I'm considering 15 years for this example. So that's that those set of parameters. Now moving on to the next set, the energy parameters. So these are very important while we do the calculation for pollution. There are two sets of these parameters, one for the ICE car and the other for the EV car. So first I'm considering the mileage of an ICE car versus mileage of an EV car. So I'm considering 12 kilometers per liter as a normal average mileage one would get in ICE car. I know it could also go up. We will check it when we do the demo. We will try to increase the mileage and see what happens. And for the EV cars, I have done this calculation based on various EV models. Actually, it is more than 6 kilometers per unit of electricity, but I'm just considering 6 as a baseline. Now, most of the EV cars don't tell you what is their mileage in terms of kilometers per unit because all of them talk about range. But for this calculation, I need to know uh, kilometers per unit as a measure. The next parameter is the CO2 emissions caused by ICE car versus EV car. This is while the car is running. It's like the running emissions caused by these cars. I have referred to some of those websites that I have mentioned here. The source is mentioned there. So, an average ICE car causes 2.3 kgs per liter of fuel burned. So, that is the carbon emission for ICE car. Whereas for EV, it is 0.713 kgs of carbon that is emitted per unit of electricity produced. Now, this number is slightly dicey because it depends on which country or which state you are drawing the power from. Some countries are do use more coal and natural gases, whereas other countries use less of coal and natural gases. So this parameter changes. I am considering India average here, taken again from this website. So there, here it says it is 713 grams of CO2 emissions per unit of electricity produced today. So that's that parameter. The next set of parameters is the emissions caused during the manufacturing process of the car. You can see here ICE car, it takes about 8,500 kilograms of carbon emission while producing the car, whereas for the EV, it is higher, 14,300 kilograms to produce 14,300 kilograms of CO2 emitted to produce one EV car. These are rough figures. Again, the source is mentioned there from where I got these numbers. These numbers are not cooked up by me. So I'm just sharing a screenshot so you can see here the numbers. Actually, it is somewhat higher for the ICE car, but I'm just considering in this example 8,500 kilograms for ICE car. And for running the scenarios, I have developed a local application. You will not see it on the internet, and it looks something like this. I'm just sharing the screen grab so that you can see it more closer because when I run the demo, it might look very small and you might not know what is what. So I'm just showing it here. All the parameters that we discussed just now are all mentioned here in this form. So next, I'm going to head over to that application and show you a demo. Okay, here we are. This is the application I was talking about. First, we will try with an example of 8 years of running the car at 20,000 kilometers per year. And I've inputted all the parameters that we discussed a while back. So 8,500 kilometers, 8,500 kgs of carbon footprint, and every parameters I've added. And let's see what we get here when I submit. Let me zoom in a little bit so that you can see it a bit better. All right, let me see a little more. Okay, maybe this looks good. So let me explain what is happening here. You will see a table where every year, at the end of every year, what is the total CO2 emission for an ICE car versus EV car. So this is a tabular representation, and on the right side, you will also see a graph so that those who are comfortable with graphs can see the graph, and those who want to see the numbers can see this table. So what is happening here is the first year you are, if you have an ICE car, you have emitted 12,333 kilograms of carbon. This is carbon emitted during the production of the car, which is 8,500 plus whatever carbon emitted for running 20,000 kilometers. I'm calculating it based on the mileage factor given here and how much is the carbon footprint per liter or per unit, whether it's based on ICE or EV car. So the ICE car emits 12,300 kilograms of CO2 at the end of the first year, whereas EV emits 16,677 uh, kgs of carbon dioxide. So it is higher, and you'll see these tick marks, which is like which is the winner of the two in first year. So clearly, ICE has polluted less by the end of first year. This is a total pollution and not the pollution caused just while running 20,000 kilometers. So you will see this number. So it goes on for second, third year, and when it comes to fourth year, this is where you will see that the EV car has caught up with the emissions compared to the ICE car. So in this example, the EV car has emitted 23,800 kilograms of carbon, whereas the ICE car has emitted roughly the same amount, but it's just less by a small margin. And as you go on driving EV car over the period of years, you can see that this gap widens, obviously. And you can see in the graph here, the two graphs, the blue one is the ICE car and the green one is the EV car. You can see that roughly around the third year mark, you have both the cars have emitted the same amount of carbon, and after that point, it is always the EV that is winning. So less pollution means good. So EV has polluted less compared to the ICE car. And now, if I extend this to the life of the car, if we consider 15 years as the life of the car and see what we get, you will see that over a period of 15 years, the EV car has cost 49,000 kgs of CO2 emission, but the ICE car has cost 65,000 kgs of CO2 emission. So you can see this gap widening and widening as the year goes by. So what is called as from cradle to grave emission, clearly EV is the winner here for this kind of a usage, 20,000 kilometers, 15 years. Now there's another angle here. I've added solar energy. Or before discussing solar energy, what I wanted to tell you here is this number, 713 grams per kg of um, per unit of electricity produced, right? So this is the figure today. But as we go more cleaner and cleaner electricity production, this number is going to reduce. It is going to reduce much more than the CO2 emitted per liter of petrol cars, right? So that is going to happen. But I'm considering today's scenario. If we consider today's scenario and if we maintain the same level of electricity production mix, then this is what we are looking at. But most likely, this green line will flatten and flatten because there are more initiatives for the cleaner energy in the energy sector. So that's bound to happen, but I'm just considering what is there today. Now, the other angle is the solar energy. If you have an independent house with some space in your terrace, then it is advisable that you go for solar energy. Even if you're not going for a EV car, please install solar so that you can get free electricity for about 15 to 25 years roughly, and the electricity that should have come to your house can be used by another house which wants to use EV, for example. So let's see what happens when I switch this on. If we consider somebody having a solar energy and have running an EV car, how does the equation looks? So you can see here the emission caused by EV car is flattened right away, right from the first year. So it is just what is cost during the production of the car, and after that it's going to be flat. And you can see the difference between the ICE car emission and EV car emission in this kind of a case, right? So you will see again a total of 65,000 kilograms of CO2 emitted versus roughly 14,000 kilograms of CO2 emitted. So that is the difference, and it is huge. I know you would say that not all of those kilometers run are using solar power. There may be some mix where you draw power from the grid or from public charging infrastructure, but I'm just showing you theoretically what happens if you go for a solar panel and an EV, right? So you are saving a whole lot of pollution, and I could not get an exact figure of how much pollution is caused while creating solar panels, but I'm pretty sure it's not so huge. So there is some pollution caused while producing solar panels, but that's also one time. So I expect this graph to be slightly above, but definitely not to these levels. Now, let's change this to a heavy user scenario, like somebody like a fleet operator or somebody who travels a lot, 40,000 kilometers in a year, which translate to about 6 lakh kilometers, which is highly insane number, but just for calculations, let's see the emissions in this case. So in this case, if you see straight off the bat, within a few days itself, the EV car or the ICE car emissions exceeds the EV car emissions. You can see it here. Within the first year, the ICE car has emitted more than the EV car. And if you see the total, you're talking about 1,23,000 kilograms of CO2 compared to the same CO2 levels that you saw in the other examples, right? So that is the effect of having solar panel and the pollution for this kind of a heavy usage. Now let me just switch off the solar energy and see how is it for this kind of a scenario. So it is 85,000 kilograms of CO2 emission for EV cars versus 1,23,000 for ICE cars. So the difference is still huge, as you can see here. So this hopefully rests the argument that EV cars also pollute, and it pollutes more than the ICE car. The EV cars do pollute, but over a period of time, from cradle to grave emissions, if you consider, it is always the ICE car that pollutes more than the EV car. Now, for the sake of completing this demo, let's check for a user who just uses 6,000 kilometers a year, the rare usage kind of a scenario, right? So for 15 years, 6,000 kilometers with no solar panel and all of these figures. If you see here, you can see that it does take a lot of time to catch up between the two cars. So for example, it takes about 13 years before EV cars make sense over the ICE car. So what I wanted to draw a point here is, like, if you are somebody who is using the car very rarely, like 6,000 kilometers a year, then you are not polluting much even with the ICE car. So maybe going for an EV to reduce the emission doesn't make sense for this kind of a usage unless you go for 12 years or more. Only then it catches up, and the difference is very small, as you can see here. If you see the end figures, it is 24,900 kilograms versus 25,700 kilograms. So the difference is very less. So if you use the car less, then um, this difference in emission is also going to be less. So that's the point. But if I say yes for solar energy in this kind of a scenario, then what we get is somewhat better. Like after fourth year, both the cars catch up, and then afterwards it's the ICE car which keeps polluting more, and the EVs pollute less. So that's the scenario. So even in this scenario, if you have a solar panel, then it makes sense to have an EV car or an ICE car, and that's the point I wanted to draw here. Now, I should also consider hybrids because nowadays hybrids are becoming popular. So, how does this scenario look for in the case of a hybrid? So, again, going back to this form, so I'm considering the example of 8 years, 20,000 kilometers, the normal usage, no solar panel. Now, the CO2 footprint of a hybrid car obviously is going to be more than a petrol car because you have a battery and you have an engine and the normal manufacturing that is needed for a petrol car, right? So it's a both worlds. So I will add these two figures, the pollution cost. So let me make it like 20,000 kilograms of CO2 footprint because hybrid has both battery and the engine. So it starts on the higher side compared to EV. But where it makes a difference probably is the mileage. So this mileage is going to be more for a hybrid. So I will consider 20 kilometers per liter as a mileage for this kind of a hybrid car. So now we're comparing hybrid, higher carbon footprint, but a better mileage, and let's see how the numbers look. So this is an interesting graph. If you see both the ICE car and EV car lines are going parallel to each other, but ICE car it starts off with a higher number and keeps growing at the same rate. So the CO2 emitted is probably the same while you run the car, but because you used both the engine and the battery for production, it is slightly higher than the ICE car. So you will see here the numbers for the life of 8 years and 20,000 kilometers of running. So you will see that EV car has emitted 33,000 kgs of CO2, whereas for a hybrid car has emitted 38,000 kgs of CO2. So hybrids are still higher, but it is way better than the pure petrol car example that we saw earlier. And in this case, if we have a solar panel, obviously, I guess we will see a clear demarcation here. So the line for EV gets flattened because you are producing or you are consuming electricity produced by the solar panels, so therefore zero cost, zero emission rather, and you see the gap here. So if you see the example, it is 38,000 versus 14,000. So a significant figure. So in a nutshell, hybrids are better, obviously, and you have seen how much better compared to and pure petrol car, but still they don't match up to the same level as EV car, whether you have a solar panel or you don't have a solar panel. So that's the point I wanted to bring up. So in a nutshell, what we have seen is that in most cases, the CO2 emission by EV is lesser compared to CO2 emissions by a petrol car or a hybrid car. And we are considering from cradle to grave emission, meaning from the birth of car till the car is junked after 15 years. So that's the scenario we have looked at.
Now, in this example, I have not considered the effect of catalytic converter that is there in the ICE cars. Catalytic converter does help to reduce the pollution, but I will think that it will be offset by the fact that petrol has to be brought in from the place where it is extracted to the petrol pump. So it goes through various phases of emission. So both of them will probably nullify each other. So that's why I have not considered catalytic converter effect in this pollution.
I hope this bursts the myth that EVs also pollute. The electricity is also causing emissions and things like that, right? So it's all true, but if you really look at the numbers and practical scenarios, it's the EV cars that pollute less than the ICE cars. Only in the case of somebody who's driving the car, very rare, for them, it doesn't make sense to buy an EV car to control the pollution. So that's the essence. I'm sorry this episode took much longer than I expected, but I had to explain this and draw a point, and that's why it took so long. We will see you again in the next episode where I talk about the costing factor for a similar sort of a scenario. Thank you.